Hello, we are the AudioPhiles. Nathan Hurley and Yashi Me. Our semester project is Audio Alchemy, decoding sound for smarter UX. The project had two main goals, language recognition and genre recognition. The language was meant to be able to pick out any language being spoken in a song, and the genre was meant to be able to recognize different genres in the hope of being a user recommendation system in the future. Data files and extraction workflow. So it involved a big pipeline, starting with user input, where we hand wrote down things we liked, songs and CSVs. Data completion via web scraping, Python scripts. More data completion via YouTube integration of getting songs off of YouTube. That was the audio acquisition. Feature extraction then became a big deal, which took about 15 hours, where we had to scrape things from the songs we got off of YouTube. Finally, output files and storage, JSONs and CSVs for features and file pointers. Feature scraping, anything from fundamental frequency to some energy frequencies, key, duration, tempo, track type. I just more or less looked up things that Python could do, and I decided to start there and use them. The male spectrogram is specifically for human hearing range, 0 to 20 kilohertz audio, and that comes up later. Okay, question number 1 was language recognition. The goal was to classify songs by language using audio-derived numerical features. The data set was about 120 tracks, which expanded into 3 because every track became the track itself, just vocal and just background. We did that with the demux library from Python. It worked very well. We standardized numerical features and coded target variables. We stratified k-fold for cross-validation. And the models we picked were logistic, random forest, and linear. The evaluation results, overall, surprisingly low, but better than what comes later. Right around 50%, I would say, for most, which is, I guess random chance. It's getting it right or getting it is not. When we look at the results this way, we do see some grouping between vocal, complete song, and no vocal. So the model, I think, is picking up something. So maybe with further tweaking or hyperparameter sweeps, we could flush something out of it. Summary, so we designed a supervised machine learning model, a pipeline for the audio features, 3 classifiers. The best, which isn't really saying much here, is linear SVM, and that performed the vocal-only data. Overall, about 50% performance. So at the moment, vocal features aren't sufficient, but that just means we might need to tweak the model, I think. Research question number 2. So that's genre recognition. We had to classify the genre by audio-derived numerical features. So the pipeline was dataset, preprocessing, validation, hyperparam tuning. The models we used were KNN, random forest, and CNN. Here is the KNN stats. So top left, we have hyperparameter sweep. Top right, we have learning curve. Bottom middle, we can see the accuracy is 13.5%, which is pretty awful. So awful, you think maybe there's something going on there that's worth learning. We know it's a bad model because the training score is flat, and that means it is not generalizing at all. Same here for the random forest. We see the top right learning curve is not generalizing at all again. This time our score was a surprising 92%, but we can see by the way the training actually is behaving, it's just not believable in terms of how valid the model is. Gray stats, so here's the mel spectrogram I talked about before. We take an audio file and turn it into an image. It's there on the bottom right. It's a grayscale image. We look at our score, and we see our accuracy is 10%, which is really bad. If we look at our learning curve, now the accuracy line is very flat, which means it is failing to generalize unseen data. So again, not a model we can trust. Same idea here, only now in color. Bottom right, we see a Redis color map. Our precision and accuracy, our accuracy is 10%. We see our learning curve is flat on top again, so it's just not generalizing correctly. Summary, so we build our pipeline, that's great. We set up some models, KNN, CNN, random forest. That's great. We wanted to get that done. I believe the data set was just too small. I don't know how large it needs to be, but I think a lot larger, 10, 20 times larger than 200 songs, which should take a while to collect. I think there's something there. We just need to work on the hyperparameters and the size of the data. For Q1, it was interesting that it did pick up on vocal versus non-vocal features. And for Q2, I think the problem is just we need more data. And if not, we might need different features or both, but I think we just need more stuff to train on. All right, thank you for listening.